Hello, everyone. This is the beginning of Unit 6, Systems of Linear Equations and Inequalities. So you already learned a little bit about systems of equations when you did linear and quadratic. Now we're just going to do two linear equations and also looking at inequalities, linear inequalities, graphing and solving them. This will be a little bit of a shorter unit. Probably will just take about 2 weeks to go through. So today we're going to learn how to solve linear systems of equations by graphing. So kind of reviewing how to graph a linear equation in slope-intercept form, and also a couple standard form examples. So this says business rents inline skates and bicycles. The price per skate is $15, and the price per that's 15, and the price per bike is $30. Okay, and then it says during one day the business has a total of 25 rentals and collects $450 for the rentals. Create two equations to represent the situation, letting x be the number of inline skates and y be the number of bicycles. So we've done problems like this before, but it was a long time ago, back in unit like 3 and 4. So the two equations you want to make, the first one is going to be for the number of bikes, and the second one is going to be for the cost, the total cost. So the total number of bikes we know is 25, and the number of bikes are represented by x and y. So we could just say x plus y equals 25. And then the second equation for the price would include the price per bike. So we could say $15 per skate. So $15, or you don't even need the dollar sign. So 15x and then plus 30 per bike. So 30y equals the total amount that is collected, $450. And then it says use your equations to find the number of skates, pairs of skates rented on the number of bicycles rented, and the number of bicycles rented. So the easiest way to graph an equation that's in standard form like this, remember ax plus by equals c, is to find the intercept. So remember, in order to find the x-intercept, I wonder if this will work. In order to find the x-intercept, you would cover up the y. So here, well, that didn't really work. Maybe I could have a solid figure. So you cover up the y. So here, the x-intercept would be 25. So you'd have 25 comma 0. And then if you cover up the x, you get y equals 25. So the y-intercept is 0, 25. So to graph this equation, we would plot 25 and 25, and then draw a straight line through them. And remember that now I'm posting these notes in the Polaris folder. So these notes are in the folder of the day that this puzzle was assigned, so Friday. So you can print off these notes if you want, or if you're in person, then make sure you pick up the notes at the end of class. So for the other one, if we wanted to solve for the x-intercept here, then when the y is 0, we would cover up the y, and then we would divide 450 by x, which is 15. Sorry, 450 divided by 15. And then 450 divided by 30 would, 450 divided by 30, I think I'm mixing them up. Yeah, sorry. 450 divided by 15 should be 30. And then 450 divided by 30 would be 15. So 0, 15. Okay, so if I plot those ones, I get 30, 0, and 0, 15. If I draw a line through them, then the solution is where the two lines intersect, which would be right here, which is about 20, 5. So that would be 20 skates and 5 bikes. Okay, so moving on. So a system of 2 linear equations is 2 linear equations with 2 unknowns. So 2 linear equations with 2 unknowns. And then a solution is the coordinate that is a solution to both equations in the system. So basically the coordinate where they intersect. The coordinate, so whenever you write your solution, you would write x comma y, where they intersect. So you can solve an equation. So to solve an equation by graphing, you want to get it into y equals mx plus b if it's not already there. Or you could use the intercepts, or use intercepts like we did in the opening example, and then plot the y-intercepts. So plot y-intercept, and then we use the slope to make another point. So use slope to get more points. And then find the coordinate where they intersect. Do it for both of them. So plot both equations. Find where they intersect. All right, so let's look at some examples. So y equals 3x. Well, 3x plus 0, so the y-intercept would be 0, and then the slope is 3 over 1. So you would go up 3 and over 1, or you could go down 3 and left 1. That would also make a positive slope. So then I would graph my line. And then for the other one, it's 4x minus 1. So this has a y-intercept of negative 1 and a slope of 4. So I would go up 4 over 1. And then that's all I can do. I can't go down 4 over 1 because that's off the graph. But that's all I really need to do because now I see where they intersect. So they intersect right here at 1, 3. For this one, we're going to need to do some converting. So first I'm going to subtract 2x over to this side. So I get 2y equals negative 2x minus 6. And then I have to divide everything by 2 because I got to get y by itself. So that would make just negative x minus 3 if I divide this by 2. All right, so then if I plot it, I plot negative 3 on the y-axis, and then I'm going down 1 over 1. Now, since this is goes in 3s and then this one goes in 3s, I can go down 3 over 3. And then up 3 over 3, up 3 over 3. So that's probably enough to graph if I keep following that trend. And then for the other one, I would add the 5x over to solve for y. So we get y equals 5x plus 15. So the y-intercept is 15. And then I could go up 5 over 1, but I can't. So I'm going to go down 5 over 1. And we can go just down 1, 2, 3, 4, 5 over 1. Because technically this is down 15 over 3, which is the same as down 5 over 1. Right, and then I see where they intersect. They intersect at negative 3, 0. So pretty easy once you just remember the graphing part of it. All right, so here for this one, I'm going to subtract x over. So we get negative y equals negative x plus 9. I can't have a negative y, so I'm going to divide everything by negative. So I get y equals x minus 9. So graphing this has a y-intercept of negative 9, which is kind of hard to see. This goes 2, 4, 6, 8, so negative 9 would go here. And then the slope is 1, so I would go up 1 over 1. Up 1 over 1. So since you're kind of in the middle, if you go up 1, you're going to be in the middle of the next one. Up 1 over 1, up 1 over 1. All right, and then for this one, we're going to subtract 3x, and then we get 2y equals negative 3x plus 2. Now I have to divide everything by 2. So I get y equals negative 3 halves x plus 1. And then this has a y-intercept of 1. and a slope of -3/2. So I would go down 1, 2, 3 over 1, 2. And then I see where they intersect. I'm just going to continue to graph this line. And then they would intersect at 4, -5. All right, one more. This one, subtract 2x over. So I get y equals -2x minus 4. So this has a y-intercept of -4 and a slope of -2. So I could go down to over 1. Or I could go up to and over 1, up to over 1. Okay, so there's that line. And then let's make the other one. So I would subtract x, so I get -y equals -x minus 8. We got to flip the signs again because the y is negative. So y equals x plus 8. So y-intercept of 2, 4, 6, 8, and then a slope of 1. So if I go up 1 over 1, that's great. I can make a point here. But I could also go down 1 over 1 and down 1 over 1. In edge elastic, it'll like automatically make the line. But if you're not working on edge elastic, then you'll want to do it this way. But then again, when will you not be working on edge elastic? Okay, so anyways, the point of intersection would be 2, 4, so -4, +4. Okay, and then I think we're going to skip the word problem because this one was always kind of confusing. That's okay. But I wanted to show you this example. So it says, the 3 lines given below form a triangle. Use Desmos to find the coordinates of the vertices of the triangle. So follow along with me because this one is an interesting example. I'm going to take Desmos and I'm going to type in these 3 equations. And the nice thing about Desmos is that we don't have to get it into y equals like our calculator. We could just plug it in as the equation is written. So I'm going to type -3x plus 2y equals 1. And then I'm going to type 2x plus y equals 11. Now be careful though, because if you're doing this on your test, I might not give you the Desmos graphing calculator. So you don't want to just rely on your calculator for the graphing. You want to know how to actually plot an equation. Okay, so I put all the equations into the Desmos, and then this is the triangle that it's talking about. So the question here is to find the coordinates of the vertices of the triangle. So this would be these 3 points where they intersect. So 1, 2, 5, 1, and 3, 5. So what was it? 1, 2, 5, 1, and 3, 5. So we'll be doing Desmos and graphing lines later after air testing in a trig project. Okay, so that is the end of this lesson. So I hope you enjoyed it and you guys have a nice weekend.